Hello everyone, welcome to iitiansgateclasses. This is lecture 13 on compiler design, and in this lecture we are going to start SDT or syntax directed translation. If you remember, I have already given you small introduction about SDT in the previous class itself, but let me revise all those concepts and then we will start our today's class. So, what exactly is SDT or syntax directed translation? See, there are lots of errors that are not detected by syntax analyzer. So, what kind of error can detect syntax analyzer? Like semicolon missing, opening bracket is present but closing bracket missing, and so on. So the golden rule is if you are not able to write context-free grammar for any error, then that error won't be detected by syntax analyzer. Syntax analyzer can detect only those errors for which we can think we can write context-free grammar. Okay? Yeah. For example, here's semicolon missing and so on. So yes, so for example, see, I have given you a few examples of errors which are not detected by your syntax analyzer. For example, variable is not defined before its use. So how you will write context-free grammar for it? I think that is impossible. Similarly, type checking, like A is integer, B is float, okay, and we are adding them. So how you will check that A data type is int, B data type is float, and so on. So we cannot write context-free grammar for such cases. Similarly, for assignment operator, left hand side should be variable. But if constant came, then obviously we cannot detect it. Okay? These are few errors which are not detected by syntax analyzer, or for these errors we cannot write context-free grammar. Okay. Yeah. So okay. So and see, type checking was this, okay? And this is also type checking only. Okay. So assignment operator on left hand side is variable, but constant is coming and so on. So wherever we have to check the data type, okay, that is the basic meaning of type check. Okay. Yes. So SDT. So what is the input to SDT? Syntax tree or parse tree. And what is the output? Annotated parse tree. Annotated means labeled parse tree. Okay. Along with the parse tree are labeled. Okay. Yes. So see, I have given you example in the previous class itself. Anyway, I'm not going to repeat it. It will waste our time. Okay. And I will show you more examples. Okay, that will give you more clarity about SDT. Okay. Yes. Please pause the video. Note it down. Yes, so now I can say you see in one line how you will define SDT. So the entire process of SDT, we can think like entire process of SDT, okay, entire process of SDT is to attach. So what exactly we are doing? See here, let me tell you something and then I will write the statement. See, entire process of SDT is all about what? We have generated a parse tree, and to each node of the parse tree, we are attaching some attributes and we are calculating the value of attributes according to the semantic actions given. So these are the semantic actions or semantic rules. So according to these semantic actions or semantic rule, values of these attributes are calculated. So in summary, I can say what exactly SDT is doing. So entire process of SDT is to attach each node of parse tree with certain attributes, and we have to calculate values of these attributes according to the semantic action given. Okay, and we can calculate them in actually two ways: top down and bottom up. Okay, I will show you, don't worry, I will show you all these things. Okay, so now let me write the statement. So entire process of SDT is to attach each node of parse tree, with attributes. That means we are labeling the nodes, na, which we have already studied in the previous class. So we are labeling. Okay, so see, output of SDT is what? Annotated, or you can say labeled parse tree. Okay, yes. So with attributes, and we have to calculate, and we have to calculate values of these attributes. We have to calculate values of these attributes in top down or bottom up fashion. Bottom up fashion. So we have two ways, top down or bottom. Anyway, I will show you all these things. Okay, so now let me give you one more example of SKT so that you get more clarity. I'm jumping to next slide. Please pause the video and note it down. I hope you have noted down, and I'm jumping to next slide now. Okay. Yes. So now I will show you one example. So for example, if I say E goes to E plus T, or E goes to T, T goes to T star F, or T goes to F, and F goes to num. Num means number. So semantic actions are given to us as E dot val is equal to E dot val plus T dot val. Okay, and here E dot val is equal to E dot val. Now you may get confused. E and E are same. So here this is E and this is E. So I will label it as 1. Okay, and I will label it as 1. So just to differentiate. Okay, so these are same actually. This is left recursion. Okay, E goes to E and so on. So I have just shown this one to differentiate between these two. Okay, so which is left and which is right. That's why I have written it. Okay, so I can label here also T1. I will say T dot val is equal to T dot val multiplied by F dot val. Next here, T dot val is equal to F dot val, and here F dot val is equal to num. These are the semantic actions. And in GATE exam or in any competitive exam, you will find grammar will be given and the semantic action will be given, and they will say you find the value of 2 plus 3 multiplied by 4. They want you to find this value. So how you will find the value? So this is a string given to you. This is a string and they want you to find the value. So see the previous slide, I have told you there are two ways, top down and bottom up fashion. Let me show you bottom up fashion first. Okay. So okay, so let me do it here only. Okay. Yes, so first step is you have to construct the parse tree. 2 plus 3 star 4. So how you will generate 2 plus 3 star 4? I will say E goes to E plus T, E goes to T star F, E goes to T, T goes to F, F goes to num, T goes to F, F goes to num, and F goes to num. If you are not able to draw the parse tree and so on, you have any confusion, please watch my TOC lectures. These are very basic things. Okay, I think you already know all these things, how to generate this and so on. Yes, so now uh, num na. So for number can be say number can be any number. So let me write it properly. So we want 2 plus 3 star 4 na. So I will write here 2, 3, 4. Okay. Now I will start. Okay. So now first I am showing you bottom up fashion. Bottom up fashion. So see, we will scan this parse tree top, down, left to right. Okay. Top, down, left to right. Okay. And whenever we find a reduction, we will simply apply the semantic action. Please try to note it down yourself. I'm not writing just to save the time. You have to scan the parse tree top, down, left to right. Whenever there is a reduction, just apply the semantic action. Okay. So let's see. Let me take here. So, top, down, left, right. Any reduction? Any reduction? Yes, we have got this reduction. 2 to num. Sorry, 2 to f. So see here. F dot val is equal to num. I will apply. You can say uh, attribute, that is f dot val is equal to 2. Okay, f dot val is equal to 2. Now see any reduction? Yes, we have got the reduction f to t. So f to t. See here f to t. T dot val is equal to f dot val. Okay, so I will write here t dot val is equal to 2. Okay, now again I will move ahead. Any reduction? No, there is no reduction here. There is no reduction here, no reduction here. Yes, any reduction, any reduction. Yes, again we have got the reduction 3 to f. So 3 to f. So f dot val is equal to num. Okay, so I will write it f dot val. F dot val is equal to 3. Okay, then see here f to t. So I will write here t dot val. T dot val is equal to 3. Okay, now I will move ahead and see here. Again, we have got a reduction 4 to f. 4 to f means f dot val is equal to 4. Are you getting it now? See, I'm just applying the semantic actions. Now see here. Okay, see here. So T goes to T star f. Na? T goes to T star f. So where it is? Yes. So what I will say T dot val is equal to T dot val star f dot val. Now again you will get confusion which is this T and which is this T. So T1, I will say T1. Okay, so now you got the idea that right hand side is T1. So this I am taking as T1. So T1 dot val is 3 multiplied by f dot val. F dot val is 4. So 3 multiplied by 4, that is 12. So our T dot val, this T dot val will be 12. Now again I will say this. Now here E goes to E plus 3. This is the reduction. So E dot val is equal to E1 dot val plus T dot val. So this is your E1 now. So E1 dot val. So where is the val? Okay, sorry for that. I forgot. Here also we have the reduction na? T to E. I forgot to do that reduction. Sorry for that. So E dot val is equal to T dot val. So this val will be 2. Okay. This val will be E dot val will be equal to 2. Okay. This was a reduction. I forgot it. E to T. Na? See here. E to T. Yes. So finally, what we are going to get E dot val is E dot val plus T dot val. So E dot val plus T dot val, that is 12 plus 2, 14. So finally, E dot val is equal to 14. So root node value is the value here. So string value will be, it will be 14. So 14 is the answer. This is how you will calculate. This is bottom of question. Let me show you one or two examples. You will get more clarity. Okay. So yeah. So let me do it here only. So let us take string as 2 multiplied by 3 plus 4. So how you will do it? So first step is generate the parse tree. E goes to E plus T. Okay, E to T. T goes to T star F. T goes to F. F goes to num. So num is 4. F goes to num, that is 3. T to F and F to num. Num is 2. So we have got 2 star 3 plus 4. Okay, are you getting it? Okay, so now I will again show you the same example. Yes, so top down, left to right. Whenever there is a reduction, I will apply the semantic action. So see here, there was no reduction till now. This is a reduction. So f dot val will be equal to 2. Again, f to t, this is a reduction. Dot val is equal to 2. Now see here, f to 3, this is a reduction. Val is equal to 3. Now see here, this is a reduction. T to t star f. So t dot val multiplied by f dot val. See, actually I am doing it very in a faster manner because I am teaching this subject from the past 12 years and this all thing is in my mind. So you have to check this semantic action and accordingly you have to decide. So f to num, see here, f to num, f dot val is equal to num. So immediately I have written f dot val is equal to 2. So t to f, so f dot val is equal to t dot val. See here, f dot val is t dot val is equal to f dot val. T to f, t dot val is f dot val. So this val will be this val and so on. So that's what I'm doing. So you just check it out from here. Okay. Yes. So now next. So t dot val will be what? T dot val will be, see here, t to t star f. See here. T to t star. T dot val is t dot val star f dot val. So you will multiply the values. 2 into 3, that is 6. Now I will jump here. Any reduction. Yes, this is a reduction. So dot val is equal to 4. This is a reduction. Dot val is equal to 4. This is again a reduction. So dot val will be what? E dot val plus T dot val. Okay, so again I forgot T to E. Na? This was a reduction. See here. E to T. E dot val is T dot val. Okay, so dot val is equal to 6. So just copy paste this val to this val. Okay, so it was 6. So now E dot val will be what? E dot val plus T dot val. So 6 plus 4, that is 10. 10 is my answer. Okay. So finally, what I will say, our answer will be 10. So I hope I have made the point clear to everybody. Yes. Now please note it down carefully, and I will jump to the next slide, and I will show you a few more examples. So anyway, I'm concentrating on bottom up fashion. Then I will show you top down fashion also. Okay. Let me do 2, 3 questions on this bottom up fashion. Once you will be comfortable in that, then I will show you top down fashion. Okay. Yes, so let me give you some more example. Please pause the video and note it down. Yes. Next example is same grammar I'm using. E goes to E plus T, or E goes to T, T goes to T star F, or T goes to F, F goes to num. Num means any number. The semantic action here is printf plus. Here there is no semantic action, and here we have printf star. Okay, so from this example, you will get more clarity about we can keep any semantic action blank also. So there is no compulsion that you have to give the semantic action. So here again I am putting blank, and here I am writing printf num dot var. Num dot var. So you have to print the value. That's it. Printf is used to print the value. I think you already know. Okay. Yes, just C language function. That's it. Okay, so now I will show you some examples. So let us suppose I want to calculate the value of 2 plus 3 star. Same example, 2 plus 3 star. What will you do? So first step will be what? You will have to draw the parse tree. Okay, so 2 plus 3 star 4. So what we will do? E goes to E plus T. T goes to T star F. E to T. T to F. F to num. T to F. F to num. F to num. Now we will start top, down, left to right. Whenever there is a reduction, I will apply the semantic action. So see, there is a reduction from num to f. So printf num dot val. So you will print the value number. Okay, and let me do it properly. So write the numbers. Okay, uh, that will be much easier for us. So 2, 3. So you can check it out. We have made the parse tree. Now we will apply the semantic actions. So let me see here. Any reduction? Yes, there is a reduction. 2 to F. So what we will say? Uh, uh, C. F to num, printf num dot val. So we will print 2. Now see here, F to T. So there is no semantic action, no problem. Then T to E. Okay, so there is again no semantic action, no problem. So any reduction, yes. 3 to F. So printf num dot well, that means 3 will be printed. Now F to T, no semantic action, no problem. So 4 to F. So printf num dot well, that is 4. Okay, 4 to F, see here. This will be printed. Now see here. T goes to T star F. So printf star. So you will print the star. Okay. Now see here. So now we will go here. E goes to E plus T, you will print plus. If you see carefully what we have done, this was infix and this is the postfix. Okay. So infix to postfix conversion we are doing. Okay, are you getting it? Okay. Please pause the video and note it down, and I will jump to the next slide now. Okay. So let us suppose next example. S goes to XXW. This is a gate question, okay? S goes to Y and W goes to SZ. Here we are writing printf 1. Here we are writing printf 2. And here printf 3. Okay. And the string is given to us as 4 times X, Y, Z, Z. Okay, we want to find value of this. So how you will find? So first you have to make the parse tree. So see here, XX now. So S goes to XXW, XXW. Now we want again X, double X. So double X can be given by S only. So W is going to SZ. We will apply this. And S will go to XXW. Okay. Yes. So now what we will do? See, we have got 4 times X now. We have got 4 times X. Okay. Then we want Y and then double Z. Y. How you will get Y? So see, there is only one possibility for W. That means SZ. So you have to apply SZ. And we want Y. So S can go to Y also. So we will apply Y. So now see here carefully, we have got X, X, Y, double Z. So parse tree we have made. Now we will have to find this value. So top, down, left to right. We will scan it. Okay. Top, down, left to right. Whenever there is a reduction, I will apply it. So are you able to find any reduction till now? Yes, this is a reduction. Y to S. So printf 2. So 2 will be our output. Now any reduction, yes. We have got here reduction. W goes to SZ. So printf 3. Yes, we have got the 3. Now see here carefully any reduction. Yes, we have got here reduction also. S goes to XXW. So 1 will be printed. Now any reduction, yes, W goes to SZ. So 3 will be printed. Now S goes to XXW, so 1 will be printed. So 2, 3, 1, 3, 1. This is my final answer. Okay, so for this string, output will be 2, 3, 1, 3, 1. Okay. Yes, I think by now you have got the got more clarity. Okay. Yes. Now let me show you one more example. Okay, so that you get crystal clarity about the idea. So I think work is very easy now. Okay. But let me give you example. So let us suppose our grammar is E goes to E hash T, E goes to T, E goes to T and F, and T goes to F, F goes to now. Here I will write E dot val is equal to E dot val star T dot val, E dot val is equal to T dot val, T dot val is equal to T dot val plus F dot val, T dot val is equal to F dot val, F dot val is equal to num, or you can say number. Okay, so this is our you can say grammar. This is the grammar, and these are the production rules, semantic actions. This is the grammar production rules, and these are the semantic actions. And we want to find value of, let us suppose we take 2 hash 3 and 5 hash 6 and 4. Okay. So how, okay, so let me do very small example, then I will jump to the big example also. Let me do small example first. 2 hash 3 and 5. So how will you do it? So obviously you have to make the parse tree first. So E goes to E hash T, T goes to T and F, E to T, T to F, F to num. And what is the num? Num is 2. T to F, F to num, num is 2. F to num, num is, sorry. Here num was 3 now. Yes. And here num is 5. Yes. So what we are going to do? So again, same thing, top down, left to right, top down, left to right. Any reduction? Yes, we have got a reduction. So what we will do? We will apply the semantic action. So f dot val will be equal to num. So f dot val equal to num. So num is 2 now. F dot val is equal to 2. Now again, t dot val is equal to 2. T to f now. See here, t to f is e to t. E to t. E dot val is t dot val. So dot val is equal to 2. Now see here. So 3 to f. So 3 to f. So f dot val is num. So dot val is 3. Now t dot val is equal to 3. I think you have got it, na? T to f. So now, yes, dot val is equal to 5. F to num is yes. And now t and f. T and f. T dot val is t dot val plus f dot val. So I will add the values. So dot val will be 8. And then e dot val we will calculate. So this is what e goes to e hash t. So e dot val star t dot val. So 2 star 8, that is 16. Here answer will be 16. Okay. Now I will give you a shortcut to solve such kind of questions. Are you able to remember this type of grammar we have used for, I have told you, levels decide the precedence, okay, and recursion shows the associativity. So left recursion means operator is left associative, okay, right recursion means operator is right associative, and so on. Are you able to remember the topic name? Yes, try to think it. Yeah, I think you are right. The topic name was Ambiguity Rules. Okay, so I think it was third or fourth lecture of of compiler design. You can check it out yourself. So this type of grammar we have used, and I have written here semantic actions. So what you will do? So if see here, if question was very big, okay, and generally such questions have been asked in GATE exam also. So 2 hash 3 and 5 hash 6 and 4. So obviously for this much big string, you cannot design a parse tree. Obviously you can design parse tree, but that will take hell lot of time. Okay, so the shortcut here is, so you have written this. Now first you see here, hash is what, star, and is plus. So first of all replace them. 2 star 3 plus 5 star 6 plus 4. Now don't do mathematics. So star will be solved plus, star will be solved first, then plus, and so on. Please do not do like this. See the grammar. So and is placed below, that means lower level. What does this mean? It will be solved first. So plus will be solved first, then star. Plus will be solved first, then star. Okay, so plus will be solved first. So star and plus, we have two choices. So plus will be solved first, and moreover, see, both are left associated. Hash and both are left associative only because of left recursion. So what I will say, whatever is coming first, that will be solved first. So star, so plus will be solved first, then star. So I will apply here bracket, here also bracket, and then because, so now see what we will get, 2 star 8 star 10. Now what will be solved, which star will be solved first? Actually it hardly matters. We can solve anyone, but according to rule and regulation, star is left associative. Now hash is left associative. So left will be solved first. So I will say like 16 into 10, that is 160. 160 is my answer. Are you getting it? So I hope I have made the point clear to everyone. Okay, and see here, I have solved till this part. Na? So till this part I can again solve. So here only I will solve, and I will verify that the answer coming is 16 or not. So 2 hash 3 star 5. So hash and uh, hash, and we have two operators. So and will be solved first. So I will apply here brackets. And will be solved first. Now hash is star and is plus. So 2 star 3 plus 5 within bracket. 16 we are getting. So I hope I have made the point clear. So in GATE exam or in any competitive exam, if you find a very big string and you think that parse tree making is almost next to impossible because it will waste a lot of time in GATE exam. So the best idea is to like this. Okay. Yes, please pause the video and note it down. And I will jump to the next slide now. Okay. Yes. So now I will show you top-down fashion. So we have the grammar. Okay. So now I will show you the top-down fashion. Okay. So same examples. Okay. Same example I am taking. Or let me take a small example that will be much better idea. Yes, this is a small example because I have just show you one time. It is just one time watch. If you got the idea, that's it. Then you can copy paste in other examples also. Okay, so for this, we will label the semantic actions. So I'm labeling them. So one, whatever label you want, you can give 2, 3, 4, 5. We will label them. Okay, and then we will make the parse string. So what is the string? 2 plus 3 star 4. 2 plus 3 star 4. Na? So I will say like this. E goes to E plus E, and here I will write 1. Okay. So you will just have to think that this one is with the production rule only. So I will write E plus T and 1 like this. Now next, E goes to T star F, T star F, and what is the rule? 3. So you will apply 3. Then E goes to T. E goes to T with 2 na. See here. Yes, T goes to F. T goes to F with 4. See here. Then F to num. F to num. I will directly write number is 2 na, and I have to write 5 here. Because of this 5. 2, 5 like this. So within circle, we are writing the semantic actions only. Okay. Yes, so now T goes to F. T goes to F with 4. See here. Now F to num. So 3 and 5. Here F to num. Num is what? 5. 2 plus 3 star 5. Sorry, 4. 2 plus 3 star 4. So I will write here 4. And what will be our semantic action? 5. Okay. Yes, so now we have constructed the past is successfully. Let me draw the line here so that you do not get disturbed here. Yes. So now what we will do. So again, similarly, yeah, same is the case with top-down fashion. Let me write it here. In top-down fashion, what we are going to do, again, we will scan the parse tree, top, down, left to right, and whenever we have semantic action, just apply it. Just apply it. That's it. Okay. So now let me show you. Top, down, left to right. Wherever we find semantic action, just apply it. So I have got this semantic action. Number 5. Number 5 is print num dot well. So that means what? We will print 2. Obviously 2 will be printed. Now see here. Yes, again we have got the semantic action 4. 4 is what? Blank. So I am just leaving it. Now top, down, left to right. Yes, again we have got 2. 2 is blank. So just leave it. So yes, semantic action, semantic action, top, down, left, right. You just have to remember this. 5. 5 means num dot well. So obviously 3 will be printed. Top, down, left, right. 4. 4 will be blank. So just leave it. Then T. Okay, so see here now. No semantic action, no semantic action. 5. 5 means what again num dot well. So 4 will be printed. Okay, then 3 will be 3. 3 is what? Printf star. So I will print star. Okay, and then 1. 1 means plus. So I will write plus. That's it. So obviously output will be same now. See, we have got this output from top down fashion and this output from bottom up fashion. Obviously answer will be same only. So you have to see a top down is also very easy. So you just have to apply the semantic action. So scan the parsing top down left to right, and whenever there is a semantic action, just apply it. That's it. Okay. So you don't need to do anything extra. So just apply that semantic action. If you want me to solve any other example, then I can solve it. So see here, I will solve it, okay, with a top-down fashion. First step is you have to label them. Number 1, number 2, 3. So now I will just write it. So S goes to X, X, W, and here 1. So I will write here 1. W goes to S, Z, S, Z, and 3. S goes to X, X, W, and 1. Now, W goes to what? Yes, S, Z, and 3. S goes to Y and 2. So I have just made the parse tree for this now. 4 times X, Y, double Z. So I have written this. So actually I have just copy pasted this. Just to save the time, I have copy pasted this parse tree only, but along with the semantic action. That's it. Okay, so how to make the parse tree, I have explained you previously. So I'm not going to explain it again and again. Yes. Now same is the case, top down, left to right. You just scan it whenever you got any, you can say, okay, top down, left to right, wherever you are getting any, yeah, semantic action, we are getting number 2. 2 is what you will print. 2. Then what you will do 3. 3 is what? Printf 3. 1 means printf 1. 3. 1. That's it. So we have done it. So just you have to scan top down, left to right. Whenever we find semantic action, just apply it. The final answer will be 2, 3, 1, 3, 1. Obviously, that is same as the previous example which we have done with bottom up fashion. Top down fashion and obviously bottom up fashion. Top down fashion and bottom up fashion are the two ways to evaluate the SDT. Okay. Yes, please note it down carefully. So that's all about your SDT. Since it is a basic course, I'm not going into details and so on all these things. Okay. So actually, there are two types of attributes: synthesized attribute, inherited attributes, and so on. So there are lots of things in SDT, but we are not jumping into that. Similarly, we have L attributed SDT, R attributed SDT, and so on. There are lots of terms. We are not deep. We are not digging deeper of all these things because it is a basic course. In advanced course, I will teach you all the things. What exactly is SDT? Okay, and what are L attributed SDT, what are S attributed SDT, what are L attributes, S attribute, and so on. I will explain all the things. Okay. This is a basic course. I am keeping it here only. Okay. I'm not going into unnecessary details and so on. Introduction is more than sufficient for you. And I have solved gate questions also. This was a gate question. Okay. It was gate question. In fact, this was also a gate question. All the questions which I have discussed are gate only. Okay, this was also a gate question. Okay, so yes, so I have discussed many questions with you also. So now we are left with only two things, that is intermediate code generation and code optimization. Okay, that we will study in the next class. So next class will be our last class on compiler design, and then our CD will be open. Thank you so much. Bye bye.